All right, now in order to fit a KNN model, you're just going to use the model very easily. But before I do that, just for the being clean and everything, let me remove the first part that I did in a bunch of previous videos and put it here. So basically, we are going to import the neighbors function, the kneighbors classifier, and call it KNN. And it's extremely simple from now on. We just say KNN dot fit X train and Y train, right? So basically, we're going to say that fit a K nearest neighbor model on the X underscore train and Y underscore train data set. What are these? The X train are the features, the Y train is the label, and that's it. We have now fit a KNN model. However, in order to see the results, so basically do the predictions, what we can do is to say, create a new data set and call it Y underscore pred, which stands for predictions, right? And that would be KNN dot predict X test. All right, what does it mean? It means that we are telling Python to use the k nearest neighbors methodology to predict the classifications for the observations that are presented in the X-test dataset. Remember, the X-test dataset included the features, only the features, the length and width of sepal and petal of 50 irises, and we want to use those observations in order to make a prediction about the correct species that they belong to, and that is going to be done through the KNN algorithm that we just trained using the X train and Y train dataset. All right, so using what the algorithm has learned from the training datasets, we now are going to ask it to make predictions for the observations in which the features are presented in the X underscore test dataset. And we're going to ask the algorithm to store those predictions in a new dataset called Y underscore pred. You can call it whatever you want, right? So we run it and it's run. Now, in order to see how what are those predictions, you can just say print Y underscore pred. And these are the predictions for your test dataset. Now, it was very difficult to see, okay, how the algorithm has done here. One way that you can test the algorithm's performance is to see how different the predictions are from the actual values that are in Y underscore test. All right. So in order to do that, you can basically say, go and create a new variable, which is the difference between the predicted and the actual values in Y underscore predict and Y underscore test, and then give me the average of that difference. So that is done through NumPy, and it's very easy. We can say print np.mean. So we're taking the average. What are we taking the average of? Where Y pred is equal to Y underscore test. All right. So if the value in Y pred is equal to the value in Y test, this is going to return a value of 1, right? It's true. Whereas if the value in pred is not equal to the value in test, meaning that the species that is being predicted is different from the species that it actually is, then the value is going to be 0, right? So it is going to create a bunch of zeros and ones for us, where 0 means incorrect prediction, where y means correct predictions. And then we are going to take the average on that. Basically, the higher this number is, the more precise our algorithm is. And in this particular case, you see that it is equal to 1, meaning that in every single case, the algorithm was able to make the right prediction. 100% of the times, the predictions based on KNN algorithm here was exactly identical to the values presented in the Y test dataset. So this video concludes our introduction to machine learning using KNN algorithm.